Algebra of sets. By algebra of sets, we mean set of laws which must remain valid while operations are being performed on sets. Obviously, there are union and intersection which are used as operations while we are performing on sets. And before we start algebra on sets and we talk about those laws, let's first take a look on these three terms. Commutative law. If we if we subtract 5 from 4, the answer is -1. But if we subtract 4 from 5, the answer is +1. Clearly, +1 is different than -1. So if we switch over the places, the answer is different. And we say that commutative law is not valid here with respect to minus. But if you were to verify this law with respect to addition, it will hold because 4 plus 5 will be 9 and 5 plus 4 will be 9 again. Now, next is the associative law. For associativity, we need 3 elements. In this case, let's take 3 elements as 2, 4 and 5. If we multiply 4 and 5 first, the answer is 20. 20 times 2 is going to be 40. But if we multiply 2 and 4 first, the answer is going to be 8. 8 multiplied by 5 is going to be 40 again. You can see that the answer is same in both cases. It doesn't matter whether we multiply the last two numbers first and then multiply it with first, or we multiply the first two numbers and then multiply it with the third. The answer is still going to be the same. So we say that associative law with respect to multiplication holds. And for the distributive property, let's take a look on these two operations. There will be two operations. The plus is in the middle, inside the brackets, and this multiplication is outside the brackets. We are going to check distributive multiplication. Is multiplication distributive over addition? So we clearly know that 2 multiplied by bracket 5 plus 7 is equal to 2 plus 5. 2 multiplied by 5 plus 2 multiplied by 7. So this is distributive law, and it clearly tells us that multiplication is distributive over addition. Let's take a look with respect to intersection and union. The first one is commutative law. Commutative law. A intersection B is equal to B intersection A. It means if we switch over places of A and B sets, it doesn't make any difference. And similarly, if we switch places with respect to union, the answer is still going to be the same. So we say A union B is same as B union A. This is what is known as commutative law. And second is associative. Associative law. And we know that for associative, we need to take 3 sets. For set A, B, and C. A union within bracket B union C is same as if we have taken union of A and B first, and then we take union with C. The answer is going to be same. This is called associative law with respect to union. Same thing for intersection. A intersection B intersection C is equal to, let's take intersection of A and B first and then take the intersection with C. These are called associative law. The first is called associative law with respect to union. The second one is called associative law with respect to intersection. Now we will discuss that union is distributive over intersection. So we can keep the union outside. A union B intersection C is same as, if we want to distribute, let's do this and then do this with C. This one is going to be the same. So A union B intersection will stay as such, and then A union C. This is what is called union is distributive over intersection. Now A intersection B union C, and this we can write as A intersection B, then this middle one union, and then this will distribute to C, and this will become A intersection C. Now this is called, and these are called the distributive laws. Distributive laws. And next very important set of laws is De Morgan laws. De Morgan laws. And these laws are very helpful in understanding Boolean algebra, but for two sets A and B, A union B whole complement is equal to A complement intersection B complement. Now here you can see that we took A union B first and then took the complement, and union actually changed into intersection depending upon if we take the union first or the complement first. But this is called the first De Morgan law, and the second De Morgan law is going to be A intersection B complement equal to A complement union B complement. These are called De Morgan laws. And if you have studied subsets and complements, then obviously this identity laws are not going to be any difficult for you to understand. Identity laws, and for identity laws, A union B, first A union null set phi is equal to what? Obviously it's equal to A. And number two, A intersection null set is going to be what? Is going to be null set. Number three, A intersection universal set. Remember that universal set is the superset of all the sets under consideration. So A obviously is contained in universal set U. So A intersection universal set is going to be equal to A. And the fourth one is, what is A union universal set U? That is equal to universal set. These are called the identity laws. And now we take a look at involution law. involution laws. And involution laws are that if we take complement of a set, then this is going to be A again. And laws of complements of complement and remember that U is the universal set is the superset of all the sets under consideration. So what is going to be the complement of the universal set? It's going to be null set. And what is complement of the null set? That is going to be the universal set. And A union A complement. A union A complement. And you know that A and A complement are disjoint sets. They don't have anything in common. But A is a given subset of universal set and A complement is equal to U minus A. So their union is going to be equal to universal set, and A intersection A complement is, there is nothing common between these two sets. This is going to be equal to null set. If we want to prove these laws, we can take an example here, and here we are going to take an example that, okay, prove De Morgan laws. De Morgan laws for the following sets. Sets. Okay, here the universal set is given. This is equal to 1, 2, 3, 4 and 5, and we are going to take two subsets of U. One is equal to 1, 2, 3 and B is equal to 2, 3, 4. That's it. So if we want to solve this, if you like, the question is prove De Morgan laws for the following sets A and B. Let's first state the De Morgan laws. So solution would be, first we are going to state what are the De Morgan laws. The De Morgan law is A union B complement is equal to A complement intersection B complement. And the second De Morgan law is A intersection B whole complement is equal to A complement union B complement. So if we take a look, what are the calculations we need to make? We certainly will need to make, we will need to find out A complement, we'll need to find B complement, we are going to find A union B for left hand side and then take the complement. So let's take, make those all necessary calculations. What is A complement? A complement is set of all the elements of U which are not in A. So we simply will not write elements of A and write all the other elements of U. So this is 1, 2, 3 is not going to be an A complement. So what is it? 4 and 5. What is B complement? We are not going to write elements of B, but we'll write all the other elements of U. So B complement will be 1 and then 5, because 2, 3, 4 are in B. the only elements left in U which are not in B are 1 and 5. So let's take their intersection. A complement intersection B complement. You know this is the set of common elements between A complement and B complement. So what is the number that is going to be included? The only common element is 5. So if you take a look on the first De Morgan law, we have calculated the right hand side of first De Morgan laws, which is A complement intersection B complement. Now we are going to find out what is union of A and B for left hand side. So A union B is going to be equal to the set of all those elements which are either in A or in B. So this will make all the elements of A 1, 2, 3 without repeating element in B. 2 is repeating, so we are not going to write. 3 is repeating, we are not going to write, we already wrote it. And then 4. Alright. Now for right hand side of the first De Morgan law, we have to find A union B complement. So we know from the definition of a complement, any element that belongs to A union B will not make it in A union B complement. So the only element in universal set which is not in A union B is 5, right? So if we now take a look on both left hand side and right hand side, we can see that both of this A union B complement is equal to 5 and A complement intersection B complement is also equal to 5. Therefore, we say that A union B whole complement is equal to A complement intersection B complement. This is proof of the first De Morgan law, and this will be true for any two sets given in question. If we want to prove the second De Morgan law, we can proceed similarly, but for second De Morgan law we will need to calculate for right hand side we are first going to calculate A complement union B complement, and what is this set of all elements which either belong to A complement or B complement. So this will be 1, then 4 and then 5. We are going to write 5 only once even though it appears twice. So this is the right hand side of the second De Morgan law. For left hand side, first we need to find out A intersection B. A intersection B is equal to what? What are the elements common between A and B? 2 and 3 are common. So we are going to write 2 and 3. And now we are going to take complement of this A intersection B complement. This is 1, 4 and 5. Now if you take a look on this 3 and 4, clearly it shows us that A complement A intersection B complement whole complement is equal to A complement union B complement. This verifies De Morgan laws. In fact, all the laws which we have learned today, they will hold true for any pair of sets, doesn't matter what. That's why we come back to the basic definition of the laws, and we say that the set of laws which must remain valid while operations are being performed on sets, This is called the algebra of sets, and you can verify any of the law for a given pair of sets. And we'll see you in the next video.